Hi everyone, this is your math guru. Today we're going to find the missing variables in the following exponential equations. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. In the first example, we have 32 to the power of y equals to 4. Before we can solve for y, we need to use prime factorization to reduce the two base. We have 32 equals 2 times 2 times 2 times 2 times 2, which is the same as 2 to the power of 5. And 4 equals 2 times 2, which is the same as 2 to the power of 2. Substituting back into the equation, we have 2 to the power of 5 all raised to the power of y equals to 2 to the power of 2. Expanding the bracket, we have 2 to the power of 5y equals 2 to the power of 2. And once the base are the same, we can equate their powers. We have 5y equals to 2. And to find y, we're going to divide both sides by 5. 5 and 5, 1. We're left with y equals to 2 over 5. In this example, we have 4 to the power of y equals to 1. Like we did earlier, 4 equals 2 times 2, which is the same as 2 to the power of 2. And substituting back into the equation, we have 2 to the power of 2 all raised to the power of y equals to 1. If we expand the bracket, we have 2 to the power of 2y equals to 1. Laws of exponents states that any variable to the power of 0 is 1. Therefore, to change 1 to the same base as 2, we know that 2 to the power of 0 is also 1. And substituting back into the equation, we have 2 to the power of 2y equals 2 to the power of 0. And once the base are the same, we equate the powers. We have 2y equals to 0. And to find y, we're going to divide both sides by 2. 2 into 1. Therefore, y equals 0 divided by 2, 0. In this example, we have 16 to the power of p equals 1 over 8. We have to find p, and changing the base to its lowest prime using prime factorization, we have 16 equals 2 times 2, 4 times 2, 8 times 2, 16. That's 2 to the power of 4, and changing 8 to the base of 2, which is the lowest prime, we have 2 times 2 times 2, which is the same as 2 to the power of 3. And substituting back into the equation, we have 16, that's 2 to the power of 4, all raised to the power of p equals 1 over 2 to the power of 3. Expanding the bracket, we have 2 to the power of 4p equals 1 over 2 to the power of 3. We know that 1 over a to negative exponents will give you a to the power of minus 1. So therefore, 1 over 2 to the power of 3 to negative exponent will be 2 to the power of minus 3. And substituting back into the equation, we have 2 to the power of 4p equals 2 to the power of minus 3. The base are the same, so we are going to equate the powers. We have 4p equals minus 3. And to find p, we divide both sides by 4. 4 and 4, 1. We have p equals minus 3 over 4. Let's look at one more example. In this example, we have 5 times 25 to the power of d equals 3125. Before we start changing the base to its lowest prime, we're going to divide both sides by 5. This cancels. We're left with 25 to the power of d equals 3125 divided by 5, that's 625. If we change each base to its lowest prime, we have 25 equals 5 times 5 using prime factorization. This is the same as 5 squared. 625 equals 5 times 5 times 5 times 5, which is the same as 5 to the power of 4. Substituting back into the equation, we have 5 squared, also the power of d equals 5 to the power of 4. Let's expand the bracket. We have 5 to the power of 2d equals 5 to the power of 4. And once the base are the same, we equate the powers. We have 2d equals to 4. And to find d, we're going to divide both sides by 2. Therefore, D equals 4 divided by 2, 2. Thanks for watching. Bye.